Welcome to the deep dive. Today, we're diving deep into Linux security essentials, and we're using the 303-300 exam as our guide.
But don't worry.
But this isn't just about passing a test.
Exactly.
It's about gaining those real-world skills.
The real-world skills.
That protect your systems.
Exactly.
It's like we're using the exam as like a launch pad to explore all these fascinating concepts like encryption, access control, and
roadmap.
Yeah. And firewall rules. We're working with a set of practice questions here that are formatted kind of like a quick study guide.
Yep, quick study guide.
So buckle up.
So while the 303-300 exam itself has 60 multiple choice questions, a 90-minute time limit, and costs around $200 to take, we're not just going to drill through memorizing answers.
Right.
The real value lies in understanding the why behind each security measure.
I love that.
That's what makes you a true Linux defender, not just someone who can pass an exam.
I love that. So let's jump right into our first practice question.
Okay.
It throws us headfirst into the world of encryption with GPG, often shortened to GPG. Imagine you need to back up your private key, maybe move it to a new machine.
Okay.
What GPG command would you use for that?
That's a great starting point.
Yeah.
Because private keys are truly the heart of your encryption security. And the command to safely export that private key is GPG export secret keys AO private key.ask.
Okay, let's break that down a bit. Export secret keys? Seems pretty straightforward.
Yeah.
But what's the significance of the ESA flag?
The ASCII armoring stands for ASCII armoring.
Okay.
It's crucial because private keys are often in a binary format, which isn't easily transferable across different systems.
Okay.
ASCII armoring converts that key into a text-based format that could be safely pasted, emailed, or stored in a text file. Without it, you risk corrupting the key during transfer.
Fascinating. So it's like translating it into a language that everyone understands.
Yes, exactly.
And then that last part, O private key.s.
Yes.
Is just telling the system where to save that ordered key, right?
Precisely. You're essentially creating a portable, secure version of your private key.
And this brings up a really crucial point you mentioned earlier.
Yes.
Protecting private keys is paramount. What are the real-world risks if someone gets their hands on your private key?
It's not an exaggeration to say it compromises everything you've encrypted with that key.
Wow.
Think of it as a master key to your digital vault.
Okay.
Anyone with access can unlock and potentially manipulate any data you've secured. So handling private keys with extreme care is non-negotiable in the world of Linux security.
Point taken. We are definitely treating those like precious jewels.
Yes.
Now on to our second question.
Okay.
Which delves into the world of access control.
Okay.
How do you control who can SSH into your Linux system? I'm assuming we don't just want anyone
Absolutely not.
Strolling in.
No.
So SSH or secure shell? It's the standard way to remotely access and manage Linux systems.
Yes.
But that access needs tight control.
For sure.
That's where pluggable authentication modules, or PAM, comes into play.
Right, okay.
It's not just about individual passwords.
It's not.
PAM acts as a framework for different authentication methods.
Right.
Letting you customize how users prove their identity.
Exactly.
And in this scenario, the key to controlling SSH access lies within the etc.security-access.conf file.
Yes.
Isn't configuring access control complex, especially if you're managing a large team or multiple servers?
It can be.
Are there similar ways to handle this beyond editing configuration files?
There are definitely tools and utilities that provide a more user-friendly interface for managing SSH access.
Okay.
However, understanding the underlying configuration files, like etc.security-access.conf, is essential for troubleshooting and fine-tuning access control rules. It gives you a deeper understanding of how the system works.
That makes sense.
Yeah.
It's like knowing how to fix your car.
Exactly.
Even if you usually rely on a mechanic.
Right.
So this access.conf file works with PAM to define who gets the green light and who gets bounced at the SSH door.
Right.
Can you give us a real-world example of how this would be used?
Imagine you have a server with sensitive data that only your development team should access.
Okay.
Using etc.security-access.conf file, you can create rules based on usernames, IP addresses, or even the time of day to restrict SSH access to only those authorized developers.
That's a powerful way to prevent unauthorized logins. Okay, on to our third question, which focuses on web server security.
Okay.
The question asks how to disable outdated TLS versions on an Apache web server.
Got it.
Can you explain why using outdated TLS is considered a security risk?
Transport Layer Security, or TLS, is the protocol that encrypts communication between a web server and a client, like your web browser.
Okay.
The problem is older TLS versions have known vulnerabilities
Yeah.
that attackers can exploit to intercept or tamper with data.
It's not as simple as like an unlocked door. It's more like having weak locks that a skilled thief can easily pick.
Exactly, yeah.
I've heard about these downgrade attacks.
Yeah.
Can you explain how those work and why disabling older TLS versions is so critical?
In a downgrade attack, an attacker tricks your system into using an older, weaker TLS version.
Mm-hmm.
Even if your server supports newer ones,
Okay.
they exploit flaws in the older protocol to weaken the encryption and potentially steal sensitive information like login credentials or financial data.
Right.
That's why disabling those older versions through the Apache configuration is crucial.
Okay, so how do we actually lock things down in Apache
Right.
and make sure that those older, vulnerable TLS versions are completely off the table?
The directive you'd use in Apache's configuration file is SSL pre-protocol, all NAT is TLSV 1.0, NAT is TLSV 1.1.
Okay.
This essentially tells Apache, allow all TLS versions, but specifically exclude TLS 1.0 and 1.1.
I see.
So you're forcing the server and client to use only the newer, more secure versions.
It's like saying we're only speaking this secure language from now on.
Exactly.
Okay, moving on to question 4, which takes us into the realm of intrusion detection.
Okay.
How can you tell if someone has tampered with your critical system files? This sounds pretty serious.
We're talking about
like
integrity.
the integrity of your entire system.
Exactly.
So think of your important system files as the foundation of your digital house.
Okay.
If someone tampers with them,
Right.
the whole structure's at risk.
Yes.
That's why file integrity monitoring is so crucial.
It is.
And one of the tools commonly used for this is AID, the Advanced Intrusion Detection Environment.
Yep.
So AID is kind of like a security camera for your files.
Yeah, like a tripwire.
Watching for any unauthorized changes.
Exactly.
How does it actually detect those changes?
AID works by creating a database of file attributes
Okay.
for all your critical system files.
Uh-huh.
This includes checksums, which are unique fingerprints for each file.
Wait, so if even a single byte in a file is changed,
Right.
the checksum would change,
Okay.
and AID would know something's up,
Exactly.
and the timestamps show exactly when that change occurred.
Exactly.
Wow.
It's a powerful combination.
Yeah.
AID regularly scans your system files and compares them to its database.
Mm-hmm.
If it detects a mismatch in the checksum or an unexpected change in the timestamp,
Yeah.
it raises a red flag,
Okay.
alerting you to potential tampering.
That's a great way to catch those sneaky file changes.
Yeah.
So it's not just about reacting to an intrusion, it's about having that system in place that tells you,
Proactive.
yeah, if someone's even attempting to mess with your system.
Exactly.
Okay, this has been super insightful. Now, on to our final question for this part,
Okay.
which dives into firewall rules and the command line tool ineftables.
All right.
The question is, you need to block a specific IP address from accessing your system.
Mhm.
What's the ineftables command for that?
Firewalls are essential for network security.
Right.
Think of them as the gatekeepers of your system, controlling the flow of incoming and outgoing network traffic.
Okay.
NFTibables is a powerful tool for managing those firewall rules, giving you granular control over what's allowed in and out.
Mm-hmm.
But before we jump into the specific command, it's important to understand a few key concepts about how NFTibables works.
Okay, I'm all ears.
Well, NFTibables uses a structure of chains, tables, and rules.
Okay.
Think of it like this. You have a table for each major function,
Mm-hmm.
like filtering traffic or handling network address translation.
Okay.
Within each table, you have chains, which are essentially lists of rules that are applied in order.
Okay.
And those rules dictate what happens to network traffic that matches specific criteria.
So it's like a hierarchy.
It is.
You've got your tables, your chains,
Exactly.
and then your rules within those chains.
Exactly.
I'm starting to see how this all fits together.
Yep.
So if we want to block a specific IP address,
Right.
which table and chain would we be working with?
In this case, we'd be using the filter table, which is designed for filtering network traffic.
Okay.
And we'd be adding our rule to the input chain, which handles incoming traffic.
Okay.
Now, the specific command to block an IP address, let's say 10.0.0 would be nft add rule ip filter input ipsatter 10.0.0 drop.
Wow, that's a mouthful, but I'm starting to see how the structure you explained
Right.
makes the command more understandable.
Yeah.
We're telling NFTables to add rule, specifying the IP protocol, the filter table, the input chain, then targeting the source IP address with ipsatter 10.0.50, and finally drop
Right.
to completely block any traffic from that address.
You got it. And this is just a glimpse into the power of NFTables.
Yeah.
It gives you incredible flexibility to define very specific rules based on IP addresses, ports, protocols, and much more.
It's like having this highly customizable security system for your network.
Exactly.
Yeah.
And understanding these firewall concepts is essential for anyone managing Linux systems.
Right.
Whether you're running a web server, a database, or any other critical service.
The world of Linux security is constantly evolving, so staying curious and continuing to learn is essential.
Couldn't agree more.
Well, I feel much more confident and prepared to navigate the ever-changing landscape of Linux security threats.
That's great to hear.
Thank you so much for being such an incredible guide on this deep dive adventure.
It's been my pleasure.
That's a wrap on this episode of The Deep Dive. We'll catch you on our next adventure into the world of knowledge and discovery.
Until then, stay secure.
Until then, farewell.